Welcome to Science versus Pseudoscience. I'm your host, Nathan Oakley, and if you are new to this channel, or you've not done so already, be sure to subscribe and hit the bell notification icon to keep up to date with the Flat Earth debate. If you'd like to support this channel, there's also a Superchat that runs alongside each of these shows while they're live, and there's a PayPal link in the info box below the video. Now, I am joined by John, otherwise known as Quantum Eraser, so first and foremost, a big warm hello to you, John. How are you doing?
Hey, Nathan.
Wow, that was super enthusiastic.
I know it was, man. I could hardly contain myself.
Are the globe heads getting you down?
Nah, it's just one of those blah days. And hard time getting motivated. Went to sleep real late last night and woke up early. I had to do both of those things, so it's just one of those blah days. We all of us have experienced those. But I know you didn't, snatch me up here to talk about, my theories on motivation.
Oh, I don't mind. I mean, I must admit, the conversation beforehand cheered me up on account of the fact that you pointed out the Dunning-Kruger in some of the guests we have, and maybe I give them a bit more credit than they deserve. And, having it pointed out that sometimes people are actually stupid, even though I, point out their stupidity and claim that they're stupid only to be accused of using an ad hominem attack, which in itself demonstrates stupidity. But there we go. It's one of those that I think, well, maybe I should beat myself up a bit less for being harsh on these people when they are, in fact, stupid. And it does get you down when you think that they're intelligent and being deceptive. So what was the term you used? I can't remember how you phrased it. Mistaking malice aforethought for ignorance. Is that right?
Yeah, it's called Hanlon's razor, and it's don't attribute to malice what can be explained by pure ignorance. So I find that a lot of cases, and it's not just here with many people. It's just ignorant. There's no malice of forethought. They're not trying to be dishonest or deceitful. I'm speaking in general terms now, right? Generally, along the bell curve, that means the biggest, fattest part of that bell curve. I mean, most people are basically honest and they're good people. So it's just something to think about. You can tell really easy if somebody is intelligent, somewhat intelligent, and we can define intelligence, but I don't want to go down that road. But people know intuitively whether somebody's intentionally trying to be deceitful or just, a bag of hammers. So, yeah, it's Hanlon's razor.
Well, maybe not. Maybe I don't understand on account of the fact that. Let's think of an example. Let's say you've got globe head on the panel and you're talking about the scientific method, and they say you're being disingenuous because you claim that you can't use any man-made equipment in a scientific experiment. And then there's a little bit more. So then you give the explanation that it's only the dependent variable that needs to be a naturally occurring phenomena. And then they tell you that you're conflating the two issues. Now, my immediate instinct would be, you've understood my explanation. We've gone over dependent variables on multiple occasions. You, the person I'm talking to, know what that is. So my explanation is sound, it's been concise. Therefore, you must be deliberately trying to obfuscate and deceive by disagreeing or claiming that I'm being disingenuous. Would I be correct in my assessment? Probably not.
Oh, I see what you're saying. No, no, no. I think that they didn't understand for the most part. Now, there's going to be outliers, like I said. For the most part, no. I think that they don't understand the argument at all. They just have surface knowledge. That's all they got. They're pretender clowns. They can parrot a headline, right? But they have no depth. So once you get just formica deep into that subject, whatever subject that you may be talking about, as soon as you go just beneath the surface, they can't deal with that. So they'll just ignore your explanation, right? And then just go off on another tangent or just stick with their parroted narrative. Oh, you're just disingenuous. You'll see that a lot. So I think that's what it is.
In other words, there's just no address because it does cause a problem, and therefore just reassert, circle jerk, however you want to phrase it.
Yeah, like I said, they can't go any further into it with the scientific method. If you say dependent variable, you just went underneath the surface of the scientific method. Therefore, most of these things are off limits to them. They can't go there. Because if you start talking about dependent variables, then that leads into independent variables, and that leads into controlled variables, and that leads into, okay, what's a hypothesis? You see where I'm going?
Well, yes and no. This is a subject we've talked about at great length over the last couple of weeks especially, and science has been hijacked. I mean, I sent out a note to everybody, including you, and Mark Sargent was good enough to read it, and the meat of it is basically that if you don't have the truth, then it's very useful to take something like science, which we were all taught at school proves things, is empirical, and dilute that down so that you can make your false claim seem credible. Now, on our side of the argument, flat earth side of the argument, we have a very, very privileged position. We've got the truth. The obvious and observable nature of our reality doesn't need scientific validation. You can use logic. You can, in most instances, especially with Ranti's photography and things of that nature, you don't even need logic. You look and you just see. And there is literally no explanation even required if you're a flat earther.
Exactly.
But if you have a religious belief in a radius value, then just looking and just seeing, that's not possible. You're not just seeing a building. You're not just seeing a boat. It's not really there. Says otherwise. My model says otherwise. My religious belief says otherwise. So let's science this now. Because what have we got on our hands, ladies and gentlemen? Well, we've got a phenomena on our hands. That building isn't really there. This is a phenomena. No. You don't need to take this step into science. But that's where the problem lies. Science isn't what they'll then be doing. They're not going to be varying and manipulating the shape of the Earth to validate their independent variable as the cause of the obstruction or whatever they're trying to pass off as curvature that day. So you don't need science to prove the obvious, and the obvious is the Earth is flat, and you can see it with your own two eyes without needing any science whatsoever. But if you're lying, then yeah, you can claim there's a curve in the way and then say it's a phenomena and then say you need to establish cause and effect relationships, i.e. the curve causes an obstruction.
Goodness, you're giving the game away. You're giving the game away, but you're exactly right. I mean, they have to conjure a phenomenon. That building or whatever you see at a distance that you shouldn't see now has to be a phenomenon, not a building. That building's not there. So it has to be a phenomenon, right? So I don't want you to give the game away because it's been going on for too long. I've been loving it, and I'm not gonna say anything to it here. I can't believe people haven't got this already. I think I've mentioned it a number of times, and ironically, it has many parallels with what we're going to do today. We're going to go through some flat Earth proofs, and I will guarantee you. By the way, I don't look at the chat. I hardly ever look at chat. So if people are, talking in chats, trying to get in touch with me, insulting me, you're wasting your time because I don't look at them. But there's a lot of parallels here, and I will guarantee you that you're going to have a number of people, either in chat or in the comments section, saying, "Where's his independent and dependent variables?" Guarantee it. I'm not going to give the answer because if you haven't gotten the answer at this point, you ain't getting it. So just continue on. Okay, Sally's?
Don't call me Sally.
Right? Don't call me Sally. Yeah. Yes, sir.
So, shall I bring your screen up?
Yes. Tell me when you're ready.
Yeah, ready when you are.
Yeah, so we went over this presentation before. It's a redo. However, I added this one in. I've had this the flight proof in there for quite some time. Not in the original presentation. I always put it below in my files. I put it right beneath. It was real small because I like the more complicated ones. But this first one, and I didn't put these in any particular order, right? But I wanted to go over this first one because what it does, the reason why I like this one so much now is it forces Joe Coffey and Betty Breadmaker to fish or cut bait immediately. Another good thing is it's really good because most people have gotten on a commercial flight before in their life, right? Not too many people that you've known have never flown at least once before in their life. So everyone can relate to this very easily. That's why I like this one so much. So flight, and it's very easy. Since the Earth is, as we're told, a sphere of 25,000 miles in circumference with a radius of 3959 miles, then pilots traveling at a typical cruising speed of 500 miles per hour to simply maintain altitude would constantly have to adjust their altitude downwards, right? Makes sense. Excuse me, to compensate for the curvature. They'd have to descend 2,777 feet every single minute. So the Earth curvature formula, based on a sphere with a radius of 3959 miles, is 8 inches per mile squared. I mean, this Pythagorean theorem, it doesn't matter, Pythagorean or trig or the sagitta, it doesn't matter. It's roughly this, and everyone knows it. So if you take this 8 inches and you use your 500 miles, right? We're going 500 miles an hour. That's what we're using, squared. So all you have to do, this is just simple math. You convert inches to feet. That'll give you 1,600, or I'm sorry, 100,666 feet of curvature. The total drop in altitude needed in 1 hour to maintain altitude, right? That's what it says. That's what you get. Very easy. So what you do is you convert feet per hour to feet per minute. What does that give you? 2,777 feet per minute. Altitude descent at 500 miles per hour to maintain altitude. This is very easy. A flipping roller coaster would be placid serenity in comparison. Here's the punchline. The nose of the plane on a typical flight would never get above horizontal, save for takeoff. No, if you've flown on a plane before and I present this argument to you, you have to fish or cut bait real quick. I did this with my neighbor. He's pretty intelligent. And this is the first one that I tried it on, right? I just said, well, think about this. He flies all over the place, right? And it stopped him right in his tracks. I could see the look on his face. Like, oh no, right? So you have to fish and cut bait with this. It's just that simple. So I don't really know any argument against this. Do you?
No, but I'm thinking about all these 666s and 777s, but I'll maybe ask you about that later.
Yeah, oh, the number, yeah. I'm not,
I'm not either. I can hear you stuttering, and I'd be the same if I was just asked that. I'm not either, but there's got to be surely there's a mathematical or logical reason why you're always coming out with these 666s and 777s when you do any globe math.
Yeah, numerology is outside my scope. I don't spend any time with it. So I'd be the wrong person to ask about that.
I'm not asking I'm saying, is there a mathematical reason as opposed to like the whatever numerological people describe their techniques as? Is there just a mathematical reason?
I have no idea.
Fair enough. Moving on.
to be perfectly honest with you, I'm not going to conjure something up.
Fair enough.
I've
I'd
looked
rather you
into
didn't.
the subject. Go ahead.
I'd rather you didn't. There's no point making it up if there's no logical or mathematical reason for why we get these reoccurring 6s and reoccurring 7s. You know, like you say, the numerology guys go nuts over it, but you know, each their own.
No, I'm not putting them down. I'm not saying I'm remaining neutral here because it's out of my scope. I won't speak to it. If something's out of my scope, you'll barely hear a peep out of me. I'll be the quiet mouse in the back, right? There's a lot of people that need to take some advice in that genre. Follow?
I'm not mentioning any names.
Yeah, we don't need to mention any names. So I don't know. Like I said, there's not too many arguments against this. People say, well, gravity. Well, even if it existed, it doesn't preclude the fact that the nose would have to go down. So I don't know. I don't know any argument against this.
But they do fly nose up though, don't they? They fly slightly angled up.
Sure, the nose is slightly angled up, very slightly. And let me tell you something: if you've flown for any amount of time, if that plane drops 20 feet, you know it. If you're in the cabin, you know it, right? So we're talking 2,777 feet per minute. So I don't know how you get around this. I really don't. I'd like to hear it. Please, somebody, put the argument out there. Don't put it in chat. I guess I can look at the comments over the next couple of days. I'd like to hear it.
Oh, that reminds me. Do you remember a guy called Gav? Maybe not.
Yeah, I know Gav.
Not Gav Beyond the Imaginary Curve Gav, a different Gav. He had a Discord server for a while. Maybe not. It doesn't matter. He did.
I don't know.
I think his channel for a time was called Flat Earth After Party. In any event, he's just released a whole series of videos of passengers going up to pilots and saying, do you adjust for the curvature? Do you do anything with Coriolis? Questions like that. And in at least 2 of them that I'd watched, the pilots are like, yeah, we know it's flat. I was gobsmacked. I must dig them out and share them with you. You'll love them. You'll love them. I'll share them with you.
Yeah, like I said, you wouldn't have... What other answer could they give? I'm not surprised at that at all. They can't give any other answer than that. Most of them, I'll tell you what, most people are just like us. We never thought about it. Well, I'm using most here generalized. I've sat, in the military, I've flown all over the world a number of times. I always got the window seat. I never thought about it once. I never looked down and said, I wonder, is the earth flat or curved? That thought never even crossed my mind, ever. So
did mine. I know we've had this conversation before.
Talked about that, yeah.
Well, I was a rep, so I was travelling all over the world, very different reasons to you. But I absolutely did consider it, not because I was considering it as a flat earther. I would think to myself, for example, I wish I could get higher to see the curve. Look how flat it looks. Now, that wasn't in any way acknowledging that the Earth could be flat, because I didn't until, I heard Math Powerland utter those words without them being in ridicule. But prior to that, I'd considered it in the respect that I'd looked out and gone, wow, look how flat it is. If only I could get up to 70,000 feet and see the curve.
Right. Well, some people are more aware of things than others. And like I told you, kudos to you.
I can figure it out. That's still credit to Math Powerland, I'm afraid. If you hadn't said it, I probably would be sitting here like a globehead right now.
Too funny. Okay, anything else? Anything you think I've missed here? This is really cut and dry.
No, well, you cover it again in a little bit with a bit of Coriolis, so obviously we'll touch on flights a little bit again.
Okay. All right, let's move to the next one.
Cool.
Go ahead.
No, that's it. Yeah, let's move on. Bolivian salt flats. Awesome.
The Bolivian salt flats. Yeah, this was one of my first ones that I ran across. Sure. The Solar, right? Isn't that breathtaking right there? I found that picture. That's really cool, man.
I stole a similar one to the one on the right, and I have it in the debates. Just breathtaking. Just look at it. It's especially both of them, but for me, especially the one on the right with that massive reflection. You can't quite believe the evidence of your own eyes. Just look at it.
Yeah, it's my icon.
It's amazing. Yeah.
Yeah, but I don't know. This, salt flats should give the game away, but yeah, apparently it doesn't. So, according to the heliocentric, sun-worshipping, spinning ball space monkey religion, every point along a tangent in every direction from your feet drops. That is, vertical drop away from you at 8 inches per mile squared. The salar in the Bolivian Andes is the largest salt, here we go again, flat on Earth, exhibiting less than 1 meter of vertical relief over an area of 9,000 square kilometers. And that's from Borsa, topography of the salar, right?
So what? I'll phrase it deliberately like this. What's vertical relief?
Drop.
So they call it relief as in how much water could run off it, right?
Yeah. Anytime you just think of vertical, and then relief is always the drop. Another way to say it is vertical drop. Relief is a form of drop you're relieving, right?
So over 9,000 square kilometers, less than a meter of drop across that entire area. In other words, it's flat, perfectly flat.
Yeah. It's a geometrical flat plane. That's what the deal is, right? Now, you can have a myriad of topographical features on a sphere. Mountains, ridges, saddles, spurs, depressions. You know what you can't have? A geometrical flat plane. It's a direct contradiction. And this one is over 9,000 square kilometers. So, how can you stage 5 cling with a kung fu death grip to your fairy tale religion that has one of its foundational tenets of vertical drop, and yet at the same time have a flat plane with less than 1 meter vertical drop over 9,000 square kilometers, pray tell? It's a direct contradiction. I mean, now that I'm thinking about it, this one is probably just as easy as the flight, right? So, let me break it down. According to the spinning ball religion, 100 kilometers, 62 miles, vertical drop should equal 781 meters. It's just what it is, or should be. But the Bolivian salt flats, 62 miles or 100 kilometers, vertical drop is less than a meter. Now, unless you can show me where those 780 meters went, you live in or on a fairy tale. The end. Right? This is over. This one's a quick one too. Right? Now, over the years, I've gotten all kind of comebacks to this, mainly straw man, red herring fallacies. They say, well, wait a second. This is based on GPS, right? What does that have to do with my argument? Absolutely nothing. Well, you have to believe in satellites then. No, I don't.
Like half a
Satellites
mile.
are on.
Is that right? Half a mile of missing drop.
Say again?
Half a mile of missing drop.
Is that how much it is? 781 meters?
Yeah, 2,500 odd feet.
There you go.
Wow.
Yeah, where is it? Nobody
Flat
can
spot.
find it. So unless go ahead.
Flat spot, like when you grind your tyres. It's a flat spot on the ball, maybe.
You can't.
Maybe it's where Thea smashed into the side of Earth. Maybe it left a flat spot.
Yeah.
No?
Yeah, you watched that Discovery Channel special too.
Love it.
How our universe works.
That's the one. Neil deGrasse Tyson, man.
Nah, that wasn't Neil deGrasse Tyson, man. That was that dude. Oh man. The garbage, the dude that always talks about the junk in the garbage. What's his name? I can't remember. And it was a few years ago anyway. So yeah, it wasn't Neil deGrasse Tyson on it. It was the junk guy.
Okay.
I'll go look it up. It doesn't really matter. But yeah, I mean, there's no arguments against this. It's a fairy tale. It's 100 kilometers. Let's take a look at this. let's go to the study itself. Let's see if it gives us a measurement here. So this is Borsa, topography of the Salar, same one I just linked to. So let's go down here. I know there's a picture down here. I've seen it before. That's where I got the information from. So here you go, right? This goes from A or alpha to alpha prime, south to north, 100 kilometers. That's the distance right here. So done. So that's 62 miles. Go ahead and put it in any curve calculator that you want. So
Yeah, I don't think you need any calculations to figure this one out. As you would put it, anybody who can fog a mirror would realise that half a mile of missing curvature. You shouldn't have any position on a sphere that's missing curvature.
Exactly. Yeah, it's that easy. So, like I said, there's not too many arguments against this except the red herring. Well, you think it says GPS, you must believe in satellites. No. Define satellites. How many they found on balloons? Bassano and I covered this over 2 years ago, right? Of these things on balloons. You guys need to go back to that. Bassano still has his videos up. Go back to Robert Bassano's channel, and you'll find it. We expose all this, all the baloney with satellites and the NASA's balloon program. It's a joke. I can't believe people still they don't even know about it.
Just before we move on, talking to Robert Bassano, one of my favourites. I don't think you were on this call, but he was chatting to a guy, some sort of technician at NASA, about Sophia and Hubble.
Yeah.
Do you remember that?
Yeah. I wasn't on that call, but yeah, I remember.
Well, he was, I don't know if I'd say out of character, I don't know if that's the right term. It was just so cool, calm and collected as he led this guy like a lamb to the slaughter, as just describing the orbits and describing how it should have crashed long ago based on their own mathematics. You know, it's
the Hubble. Yeah. I remember. Yeah, Hubble. Yeah, it should be at the bottom of the Mariana Trench because of its orbital decay.
Yeah. But it didn't just spit it out like that. He led the guy. He just led him so beautifully.
Yeah, that's right. And basically, he got the guy to admit that the telescope on Sophia is Hubble. It's got the same. It was the same specs, right? Yeah, you guys need to go back and watch those videos. They're hilarious.
Plus, so it's referenced. That was well worth referencing. So if after the show you can dig me out the link, I'll say it so you're stuck having to do it now. I will put the link to that video in the info box below this once it's rendered. So check it out. Go and listen to that conversation with the guy at NASA between Robert Bassano and this technician guy, where he leads him down the path to literally admitting the deceit that is Hubble. It's absolutely epic.
Yeah, it is. Robert had a lot of good things on his channel. The best one is it happened right off the cuff. He was talking about another subject, and he was watching, I think, one of the missions to repair the Hubble. And he was talking about how the mission was never documented. He's on that. And while he's talking about that, there's a part in the video where the astronaut has a hold of Hubble, right? And nothing's moving with the Earth underneath. And the astronaut lets the Hubble go. And the Earth and the Hubble start spinning. It was absolutely classic. Robert, he wasn't ready for it. In fact, he missed it the first time, but then he rewound it and went back to say, he goes, whoa, wait a second. What did I just see? And he said, you're free. Fly away now. It's so, I'm going to find that. I'm going to get that one for you too. It's absolutely classic, man. It's about as contrived as the weather. It was perfect, but I'll snatch that one too.
Links will be in the info box. Not now, though.
Nah, you know what? It might be a couple. I don't know when I'll be able to find. I'll find them, though, and I'll give them to you. Okay, boy, that was a tangent there. Indeed. You're welcome, Robert.
So, yeah, salt flats. Earth is flat. Salt flats are flat. Flat, flat, flat.
Yeah, flat. It's flat, man. So any arguments that you have against, there's no arguments against these. I'm just leading you into a bear trap, people. But there'll be plenty that fall into it. Just ridiculous arguments. Just go through the comment section after this video is over, and it's like, comedy night at the Ritz. So, we good on this one?
Yeah, I think so.
Okay. The next one. See, I really like this one because this sends the Baltards off the reservation. They lose their minds over this one, man. And I really like it. I like this proof. Again, it's really simple once you break it all down. So, it's the Navy's Sea Sparrow missile. And specifically, it's the Evolved Sea Sparrow missile, and it's the Block 1. Okay? The Evolved Sea Sparrow missile Block 1. Now, here's a picture of it. A couple things here that I want you guys to recognize. Number one, in my calculations below, I have this is 80 feet above sea level. Now, listen, if this contraption right here, which is the target illumination radar, we're going to get that here in a minute. If this target illumination radar is 80 feet above sea level, then I'm a mile fighter pilot, because that's not 80 feet, but I used 80 feet for the calculations below. If that, I'll tell you what, I would pretty much guess that's about 50 feet. What do you think about that, Nathan? You think I'm off the reservation with that?
I've got a pretty good idea what 80 feet is and how high one of these ships are. I've seen them visually. I've been next to them when they're docked. And no, they're not the height of a cliff.
Right, exactly. I'm saying 50 feet. I think that's pretty fair. Like I said below, I used the calculations of 80 feet. This isn't 80 feet above sea level.
But just for the sake of the audience, so can you just circle with your cursor the target radar?
Target illumination radars is this contraption down here. This is the key to the argument. Not the missile. The target illumination radars. Not to be confused with search radars, which are up on top of the ship. You know, the thing spinning around? Those are search radars. This down here is the target illumination radar. This sends out a 2-degree RF pencil beam, and it has to hit or be on the target for the missile to engage. It has to paint the target. And more importantly, from 2004 until this moment and through 2020, this target illumination radar and this missile system must be on the same launch ship. Very important. They must be on the same launch ship.
Just for the sake, sorry to interrupt again. Just for the sake of the audience, I'm going to dumb it right down. So, target, that bit I'm not going to break down because we all know what a target is. Illumination. In other words, that little contraption that John's just put his mouse over is going to illuminate, or as John phrased it a second ago, paint. So when John says paint, he means literally paint the target, put a light onto the target. So like a blob of paint, we're going to light or illuminate that target with the radar.
Exactly.
Sorry to dumb it down so much, but I want it to be absolutely clear what's happening here. That thing looks at the thing you're targeting and puts a little dot on it. Simple as.
No, it must see it. It has to see the target. This laser has to see that target. In other words, it's in fact, it's called line of sight. Right? Target has to be line of sight. As in all documentation. Now, before we get to this point, this is pretty funny. Now, if you take the height, we're using 50 feet. I'm going to use 50 feet. We'll use 50 and 80 feet. At 50 feet, according to the circle jerk curve calculators, how far is the horizon away at 50 feet tall? Well, it's about 8.5 miles. So this weapon system should only have a max effective range at this height for surface targets at 8.5 miles. There's a problem. The range is more than 35 miles, right? At 80 feet, the horizon's like 10.5 miles. Well, that's a lot less than 35 miles. And remember, this is what the Navy says 35 miles, right? Well, the official max effective range of this weapon system is classified. They only give you 35 miles. So this isn't the real one. It's at least this far. Okay? So let's move on with it. The number one, you're not going to, well, I know you're going to believe this. The number one argument against this proof is that they claim that the Evolved Sea Sparrow Missile Block 1 is only a surface-to-air missile. Okay, let me do this. You see this right here, people. Okay, this is from the Navy. General character. Maybe we should get hooked on phonics. Maybe that'll help. I don't know. Let's just go over it. General characteristics of the Evolved Sea Sparrow Missile Block 1. Primary function. Okay, it's the primary function of this missile. Let's read it together. Surface to air and what? Surface to surface radar guided missile. I know what it is. Maybe it's my voice. They don't understand my voice. Go ahead, Nathan. Can you read that for me, please?
Surface to air. I only can read that bit because I believe in a globe.
Oh, you can't see this part?
No, that's not there.
I got it. That's the problem. I got it. Thanks. Like I said, range is more than 35 miles. And like I said, it's classified, so it's a lot more than that. It's at least this far. So the missile receives a reflected signal from a target that is being illuminated with an RF signal transmitted from a fire control radar. This is the target illumination radar on a standoff platform. Such systems require that the platform maintain line of sight to the target until it is engaged by the missile. The target is illuminated with a 2-degree RF pencil beam, which has to be maintained or painted on the target until detonation. At a more than generous 80 feet above sea level, the target illumination radar height, that's what we're talking about here, target illumination radar height. The target should be hidden behind 385 feet of curvature. So please explain how you can have line of sight 35 miles away on a spinning ball by showing how a 2-degree RF pencil beam can penetrate 385 feet, that's 117 meters of target hidden height, through a wall of water 24 miles in length. Like I said again, the 35 miles is lowballing. The official max effective range is classified. It's much, much greater.
Before you go on, so you've asked the question rhetorically. So just ask it again so I can give an answer.
Which question? This question up here?
How can you have
line of sight 35 miles away on a spinning ball by showing how a 2-degree RF pencil beam can penetrate 385 feet, that's 117 meters of target hidden height, through a wall of water 24 miles in length?
You can't.
That's right.
However, in order to be able to do that, the Earth must obviously be flat.
Yes, sir. Profound. Next block of instruction, how to say Tuesdays on a Tuesday. Yeah, you got it. So to summarize, the Evolved Sea Sparrow Missile Block 1 max effective range is greater than 35 miles. Surface targets are engaged by the Evolved Sea Sparrow Missile Block 1. I put sea skimmers in here because I didn't want to forget about this. And for surface-based targets, since sea skimmers fly, that's enemy missiles fly 10 to 30 feet above the deck, we treat them as surface-based targets. I know that's probably a difficult concept for some people to understand, If it is a difficult concept to understand, go ahead and ring your call button. I'll have Tommy come back and hit you in the head with a tack hammer. Number 3, to engage, the target must be illuminated by RF pencil beam. That means it must have line of sight. Number 4, the target illumination radar must be on the same ship, launch ship, as the missile. We're going to go over that below, just to confirm it. Conclusion, either the Evolved Sea Sparrow missile, that is the Evolved Sea Sparrow missile Block 1 exists, or the spinning ball religion exists. Both can't be true. The end. Like I said, by the way, let's read through this slowly. And this is from Raytheon, who manufactures the missile. Unlike the RIM-7 Sea Sparrow missile and the ESSM Block 1, what we're talking about, unlike these two, the Block 2, that's the ESSM Block 2, active seeker will support terminal engagement, here's the punchline, without the launch ship's target illumination radars. So what is this telling you? It's telling you that our Block 1 needs the launch ship's target illumination radars on the same ship. Does everyone understand that?
It's slightly tangential, but I can assume that this has come up because people say, no, it doesn't need the target illumination radar. And no, just to preempt those people, that would be Block 2. So
yes,
the difference being 1. This is Block 1. The one that doesn't require target illumination on board the ship is Block 2.
Yes, the ESM Block 1, like I said, requires both the missile and the target illumination radars on the same ship. This is what it's saying. The Block 2 does not. Unfortunately, the Block 2 isn't going to be ready until the year 2020, with 80 missiles going to the fleet. The first production of the ESSM Block 1 was in 2002, and it has been in full operational use since 2004, according to the Navy. So, here comes the punchline. Hopefully everyone's got it by now. Please tell me how the Evolved Sea Sparrow missile Block 1 has been engaging surface targets at more than 35 miles with the target illumination radars on ships for the past 14 years. The spinning ball religion is dead. The end.
Yeah, it's only possible because the Earth is obviously and observably flat. Again, I just don't want to leave them out there with only the Earth can't be a ball. Well, no, this works because they do see the stuff. There's no curve in the way. It's just flat.
Yeah, the weapon system, there would be no weapon system then. I mean, why have a weapon system that has that range of capability, right?
Just to plug in with the YouTuber. So, oh God, who was it that made it? Taboo Conspiracy made a video where he had somebody on a submarine looking through a periscope, and he's talking to the captain and going, "Oh, I don't know if we can shoot at that one. That's probably only 12 miles away. The horizon's about 8. Could be that we can only see the top half of it. We'll give that one a miss. What about that one? Oh, that's easily 30 miles away. That's a slightly looming non-standard refraction hyena. We definitely can't shoot at that one. What about this one? Oh, that's probably only about 6 miles away. Yes, we can definitely see all of that one." And of course, in the periscope, he's just seeing boats at different distances across a vast, flat ocean.
I haven't seen that. You're going to have to make sure and give me that one. I haven't seen that one yet. Okay, like I said, the only comebacks to this are, the main comeback is this one. They will go on. It's just a surface to air. Even if I post this, right? If it's in the comment section, they'll say, "You big dummy QE. It's the Sea Sparrow, the Evolved Sea Sparrow missile Block 1. It's surface to air. You dummy." Even after I post this, right? Guess what they say?
I'm pretty
They
sure
just repeat the same thing again to me.
been covered. I'm sure I can just put a timestamp in this instance.
I mean, I don't know what to say to that. I mean, it's not even obtuse. It's exponential magnitudes beyond obtuse. Can't people read? Another important thing, and I don't get this one too much because I don't get a lot of people that can think on their feet and they can't concentrate for more than 5 seconds on a single subject. Look at this. I want to go over this. This is important. Range is more than 35 miles. Now, let me tell you something. Like I said, I'm retired military. When you have military specs on weapon systems, that's all weapon systems, the max effective ranges are very precise. That is to say, if a weapon system has a max effective range, right, it'll be delineated specifically. If there are any conditions that go against that, and let me give you an example. The M203 grenade launcher, right? Its max effective range is based on conditions. The two conditions are area target versus a point target. 350 meters versus 150 meters. They're very specific with that. Now, if the military gives a max effective range and doesn't delineate anything, then the max effective range for all conditions is this. Period. End of story. Do I need to explain that to people again? Did you get that, Nathan?
Of course.
Let me pass that on to you.
Sure.
Go ahead.
I'm good. I'm good.
So you understood that? No problem?
No problem.
I'm just anticipating, though. I haven't seen too many arguments that brings that up. The two main arguments that come up against this, that, like I said, is surface. It's only surface to air, and they think that the target illumination radars can be like on a different ship, like 3 miles away, paint the target with the missile 20 miles away or whatever. It could be what you know what I'm talking about. They think that the target illumination radars and the missile can be on separate ships. That's the only, even after I post all the supporting documentation from the Navy and from Raytheon, who made the missile, they'll just repeat the same thing back to me. I just move on.
But the only thing I might add, John, I don't know if you want to or not, just hint if you don't, but yesterday we discussed the use of Einstein's narrative against Newton's narrative, because it is the current accepted rhetoric. Now, is it worth explaining for those who naysay war?
Go ahead. I think it is. I think it's an important point. I've heard this brought up a couple times. I couldn't believe it was brought up. I figured that most people understand this concept, but go ahead, Nathan. I think you articulated very well yesterday.
Okay, well, essentially, this is the mainstream narrative, and like any good lawyer, you will pick apart the narrative of the person you are contesting. And in this instance, it makes absolutely no difference whether or not you believe. Let's just make it farcical, just so it's obvious. Let's say you don't think boats exist. Ships don't really exist, they're just a hoax. It makes no difference. This is the mainstream narrative, and their narrative says in excess of 30 plus miles. Now, if your horizon, 35 miles, if your horizon is 8 miles, then that's a massive problem, because beyond 8 miles, you're not hitting anything. Their narrative says they are, regardless of if you believe it or if it is true. So if you accept the mainstream narrative, you accept the globe religion, then you also must ipso facto accept this. This is the accepted narrative. Doesn't matter if it's true, doesn't matter if I believe it, doesn't matter if John believes it. It makes no difference, because you use their narrative against them. They say it works at 35 miles. Well, it doesn't matter if I believe, even if it's true. That's their narrative. Unless there's anything to add, John.
Yeah, I would say there's something to add. Now, a lot of people classify the military and NASA, because NASA is a military organization and the military as the same thing. Let me tell you, that is a doofus conclusion, right? Between the military and NASA, just because they're classified under the same umbrella. Listen, they don't, like I said, I'm retired military. Their specifications for their weapon systems are not lies. You know, they're just not. I've fired expert on every single weapon system the infantry had at the time. They're not lying. They don't lie about those things because they'd get called out real quick, mainly by the soldiers that are working on these weapon systems, because you have to be expert at these systems. There's special training, especially with the Sea Sparrow missile. I'm sure you have to go to an actual course. It's probably not, they don't even probably do it on the ship. It's probably a separate school, right? That's one thing. Another thing with this topic is somebody brought this up a long time. I can't remember who it was. It was really somebody stupid. They said, well, why are you using NASA's story? Do you believe NASA? And I was dumb. I was gobsmacked. I'm sitting there, wait a second. What does a lawyer do? What does a prosecutor do when he has somebody up on the stand? If he has Joe Blow up on the stand, is he going to use Betty Breadmaker's story from Lithuania to refute Joe Blow's story? No. He's going to refute. He's going to wait for Joe Blow to give his story, and then he's going to tear apart his story. Duh. Do I need to explain this any further?
I don't think so. You're using their narrative against them is the main point.
Exactly. Okay, we ready?
Yep, moving on.
All right. Like I said, one of my favorite proofs. I don't bring this proof up to people, to Joe Blows and Betty Breadmakers. I just don't, because they're so indoctrinated. The moment I say Coriolis effect to anybody, I know what they're thinking. Hurricanes. That's all I know that's what they do. They think of hurricanes. So I got to start off at step zero, try to get them out. We're going to talk about this hurricane fiasco here at the end, by the way. But I don't really bring this up to Joe Blows or Betty Breadmakers. Don't do it. It's a waste of time. But it's one of our favorite arguments, and it's really quite simple. So again, for the Coriolis effect to exist, you must have, that is necessary condition. Must means necessary. Two different frames of reference. One rotating coordinate system that's non-inertial, that's the Earth, and one non-rotating coordinate system inertial. That's the atmosphere and everything in it. From Seagar Douglas, Introduction to Ocean Sciences. This is a university level textbook. The Coriolis effect. When set in motion, freely moving objects, including air, that's atmosphere, and water masses, clouds, water vapor, move in straight paths while the Earth continues to do what? Rotate independently. Because freely moving objects are not carried with the Earth as it rotates, they are subject to an apparent deflection called the Coriolis effect. To an observer rotating with the Earth, freely moving objects that travel in a straight line appear to deflect, to travel in a curved path on the Earth. Why do they appear? Well, because you're on the rotating coordinate system. The object that's appearing to curve is not. That's why it's appearing to curve. So A, what's rotating? Well, the Earth's rotating, according to their narrative. And B, what's moving independent of the rotating Earth? Well, the atmosphere and every freely moving object in it. That's bullets, planes, balloons, anything not tethered to the Earth. Freely moving objects, like I said, are not carried with the Earth as it rotates. So, taking all that into account, if the Coriolis effect is true, and it is, see the merry-go-round and the ball. We've already done this multiple times. I've even pulled up Wiki and showed everyone this little deal right here. And you can do it on your own. Go to a playground and do it on your own. Then it's necessary conditions A and B from above. These two conditions, A, the Earth's rotating, the atmosphere isn't. It must be true. So if A and B are true, then a flight from Charlotte, North Carolina to Los Angeles nonstop traveling at 500 miles per hour airspeed with both locations roughly at the 35th degree north latitude. That is, they're both allegedly spinning at roughly 860 miles per hour, should be approximately 1.5 hours. But it's 4.5 hours. The Charlotte to Los Angeles flight, airspeed 500 miles per hour. You take the ground speed, 500 miles per hour, plus the 860 mile per hour alleged rotation speed that's coming, that's spinning underneath you. That's 1,360 miles an hour. In other words, based on the law of non-contradiction, each, the Coriolis effect with respect to the Earth, that's very important, and the Charlotte flight at 1.5 hours are either both true or both false. The flight is most assuredly false. Therefore, the Earth is not spinning. Ergo, the spinning goes by way of the dodo bird, or you're a stationary ball geocentrist. Voila, the end. You live in a fairy tale. Have a nice day. P.S. Like I said, hurricanes. Now, I'm going to give you the perfect example of no depth, no scrutiny, no due diligence, blind Wiki Discovery Channel parroting pretender clown Muppets.
But before you do,
hold on.
I just want to get everyone on the same page. So we're talking about an apparent deflection. And I'm going to hopefully get everyone to visualize this with a very simple explanation that doesn't involve somebody on a roundabout throwing the ball. So now imagine that you're on a roundabout and you're spinning around and around on the outside edge of that roundabout. And there are two friends, one at each end of the roundabout. And they, not you, are throwing the ball back and forth. So the ball is most assuredly travelling in a straight line. Because if it wasn't, it wouldn't reach the hands of the person on the other side of the roundabout. So they are throwing the ball completely independently of the roundabout. The ball leaves one person's hand, travels in a straight line, and reaches the other person's hand, and then gets thrown back again. Straight line, back and forth. Now, you, the observer in this instance, are on the spinning roundabout, and you are observing the ball being passed back and forth between these two people who are not on the roundabout. And as you observe what is most definitely a straight path, what you see from your position on the roundabout appears to curve. However, it isn't actually curving, it's only an apparent deflection based on you, the observer, and your rotation on the separate reference frame. So, just to conclude, the ball travels in a straight line and only appears from your reference frame to curve, but it definitely does not curve. It's an apparent deflection. So, just to be absolutely clear, nothing is curving. The ball travels in a straight line. End of story. Sorry, John. Carry on.
No, and another important point, when you said those two people on the rotating reference frame or on the roundabout, if you're on one end and the other person is on the other side and you throw that ball, you better lead them. Because if you throw it straight, guess what's going to happen? By the time that ball gets to where your friend is, your friend's not there anymore.
No. Sorry, maybe I wasn't clear enough. So there's three people, not two. One is on the roundabout, and two are not on the roundabout. And all the two people are doing with the ball is throwing it back and forth over the top of the roundabout, but they're throwing it to each other. So the reason I do it that way, or explain it that way, is so that you can understand conceptually that the two people who are throwing the ball back and forth have got absolutely no involvement whatsoever with what the roundabout's doing. They're just throwing a ball back and forth. And as they do so, in order for them to catch it, it must be travelling in a straight line and is travelling in a straight line. But to the person on the roundabout, as they spin around on the roundabout, they look at that ball going over the head and it looks like it curves. It doesn't. Yep. It doesn't. Yep. But by having three people, it just means that you can conceptualise the fact that the ball travels in a straight line. The Coriolis effect is the apparent deflection. So the ball doesn't actually curve. Nothing's actually curving. Everything's going straight. They're throwing it back and forth. But to your vantage point, because you're spinning on the roundabout, the two friends who are throwing a ball in a straight line, to you, looks like that ball's taking a curved path. It's not. It's an apparent deflection. Anyway, sorry.
No, that's okay. We're gonna pound on that here. Like I said, this is the perfect example of no depth, no scrutiny, no due diligence, wiki Discovery Channel parodying pretender clown Muppets, right? Hurricanes, because that's the answer you're going to get from people. As soon as you say Coriolis effect, hurricanes, right? So you're saying that hurricanes spin in opposing directions in the northern versus southern hemispheres, respectively. We've all seen this, right? Go on the Weather Channel, they'll show you. You know, they're spinning in opposite directions, right? That's an actual spin direction. It's actually happening due to the Coriolis effect, right? That's what they say. I'd sure like some of the angel dust lace shrooms you guys are smoking. In the following citations below, please focus on these phrases and terms. Apparent deflection, i.e. not actually, appears, does not actually, and this deflection is not real. This one puts the dagger in the heart, right? If these guys didn't. So the same definition from above that we just went over, when set in motion, freely moving objects, including air, atmosphere, and water masses, clouds or water vapor, move in straight paths while the Earth continues to rotate independently. Because freely moving objects are not carried with the Earth as it rotates, they are subject to an apparent deflection. This means not actually. Called what? Well, the Coriolis effect, right? To an observer rotating with the Earth, freely moving objects that travel in a straight line appear to travel in a curved path. They're not actually curving. Encyclopedia Britannica, within its rotating coordinate system, the object acted on by the Coriolis effect appears to deflect off its path of motion. This deflection is not real. I can't say this any more clearly. It only appears to happen because the coordinate system that establishes a frame of reference for the observer is also rotating. So just echoes the same thing from above up here. And another echo from the University of Oregon. The effect of the Coriolis effect is an apparent deflection off the path of an object that moves within the rotating coordinate system. The object does not actually deviate from its path, but it appears to. I think we beat this enough. So do you see all these crayon munchers? You see all this apparent stuff, right? Here comes the punchline. If you haven't gotten it by now, here it comes. Get ready. What does an actual spin direction of hurricanes have to do with the Coriolis effect, which is an apparent deflection, please? Actual, this is an argument or a juxtaposition between actual and not actual. Let me give you the answer. Here's the answer key. Absolutely nothing. That one's for you, Nathan.
Thanks.
Nothing. Right? I swear if the pseudoscience priests would repeat over and over again for the next 20 years that friggin' mermaids were the spawn of seahorses and hermaphrodite sponges, these clowns would believe it, not only believe it, then mindlessly parrot it. Hopefully everyone sees this, right? It's not actual. The Coriolis effect is not an actual thing. It's just an apparent deflection. But when you look at the Weather Channel or you get your weather forecast, those things are actual spin directions. It has nothing to do with it. If I brought up beach balls and Bunsen burners and tried to explain the difference between those two, that's what we're talking about here. We're talking about beach balls and Bunsen burners. Hurricanes and their spin have nothing to do with the Coriolis effect whatsoever. You guys follow? It's rhetorical, by the way. What do you think, Nathan? Did I miss anything here?
No, it's just nonsense. You know, there's a Neil deGrasse Tyson explanation of the Coriolis effect where he talks about a field goal going in, and He says because of the Coriolis effect, the ball enters the reference frame and the Earth carries on turning underneath, and that minor difference meant that they got the last-minute field goal. And then he moves on to explaining about how the Coriolis effect causes hurricanes to twist in different directions. It's like, well, hang on a second. The ball travelled in a straight line, the Earth continued to rotate underneath, therefore moving the goal, which is attached to the Earth, into such a position that the field goal was possible in those few minor seconds. Okay, well, that ball travelled in a straight line, so what the hell does that have to do with hurricanes? In the same way the ball travelling over my head on the roundabout carries on in a straight line, well, it's moving in a straight line. The fact that I'm turning underneath it as I observe from underneath that apparent deflection, well, what are you saying? That I appear to see the rotation of these hurricanes because I'm rotating underneath them? What a load of nonsense.
You're only apparently seeing those on the Weather Channel.
Yeah, it's apparently rotating because we're rotating. No, it's just sod all to do with anything that has any bearing on Coriolis.
And you made a very important statement at the beginning of that. You said the Coriolis causes. The Coriolis doesn't cause anything. It's the Coriolis effect. People, cause and effect, they're kind of two different things. There's no such thing as a Coriolis cause. The Coriolis doesn't cause anything. It's the Coriolis effect. Unbelievable. Okay, anything else with this?
No, Coriolis is a train wreck. I will say one thing. The Coriolis effect is real. What I detailed and what John has detailed, with separate reference frames, things travelling in a straight line, rotating reference frames underneath, that's all true. Coriolis is very much a real effect. The only problem is, we don't experience that effect on the Earth, because we're not spinning. The Earth isn't budging a smegging inch. It's not causing hour-and-a-half flight times because you're in a separate, non-rotating reference frame. None of that's true. We're just not moving. The air moves. We've got wind. Oh yeah, wind's true, because that's an objection you get when you give the difference in durations. Oh, well, I had a tailwind. That's not what they say. They say, oh, well, my flight was a different duration on the way back. You go, what are you talking about? Was it an hour and a half?
Yeah. And I make a specific effort. Right, the Coriolis effect is true. The Coriolis effect does happen. Just get on the roundabout, like you said. You can witness it. Everyone has. I mean, I did when I was a kid. But I was very specific in to say the Coriolis effect with respect to the Earth. Now, that's a different story.
Yeah, because there isn't one.
Right? That's how we defeat it.
Yeah, there is no Coriolis effect with respect to the Earth. We're not turning. There is no rotating reference frame. The Earth does not turn.
Precisely. But many people get confused with that. That could be some deliberate confusion, like willful ignorance right there. Yeah.
Nothing is turning.
Go ahead.
Nothing is turning. Moving on.
Are we okay for the last one? Are we good?
Yeah. Let's move on.
My first argument, the first one, the one that converted me in less than a Planck time. No vacuum of space, people. This one was really good. Like I said to my neighbor, I used the first argument, the plane flight, and what I think is the easiest argument, right? How do you have gas pressure without a container? That's the easiest one. I'm on propane here where I live. I got a big propane tank out in my backyard. I thoroughly enjoy hearing the truck pull up to fill up my propane tank because it gives me an opportunity to sashay my way outside and talk to the guys that are filling up my propane tank. And then we go in to discover the mysteries of gas pressure in containers. I love it. I'm looking forward to it. It has to be probably about 2 weeks from now. I'll get another one. Okay, so how do we have a gas pressure that is atmospheric pressure without a container to begin with? When the pressure of a gas is the force that the gas exerts on the walls of its container. Can't wait to hear this yarn. You can't have gas pressure in an open system. Married bachelors are more tenable. So basically, please explain how you can have tire pressure without the tire. That's what you're going to have to do. And I love seeing the shucking and jiving. It's almost like the evolutionary Texas two-step when you get globetards with this, right? They're all over the place, boy. This sends them off the reservation. Number two, how can you have a vacuum that is outer space attached to a non-vacuum Earth without a physical barrier in the same system simultaneously without bludgeoning to a bloody pulp? The laws of entropy. That is the second law of thermodynamics. Hey, in other words, how are you still breathing and adhering to your fairy tale religion both at the same time? Then define the law of non-contradiction for us. C, then please list each fairy tale associated with the outer space narrative that gets taken out back to the woodshed and bludgeoned senseless as a result of the fairy tale vacuum of space vaporizing. Number three, this is kind of fun. How in the world did the Earth form an atmosphere at all in a vacuum from a big bang? Have you ever heard nature abhors a vacuum by chance? Why do you think that is? P.S. from Arthur Eddington, The Nature of the Physical World, 1930. If your theory is found to be against the second law of thermodynamics, I can give you no hope. There is nothing for your theory but to collapse in the deepest humiliation. Now, to refute the above, and to prove your tear-jerking, belly-laughing second law of thermodynamics bludgeoning to a bloody pulp train wreck of containerless gas pressure, mind-numbing debacle akin to rib-eyeless cows, you need to go to Home Depot or Lowe's and gather the entire staff around you and ask them for compressed air. That is pressurized gas. That is gas pressure. With one stipulation, you need it without a container. After you get sued and charged with manslaughter for inducing tear-jerking belly laugher syndrome, and after you're released from Shady Meadows, you can report back here and tell us of your tale. If not, then the end, you live in a deeply humiliated fairy tale. Thanks for your ear. Have a nice day. I don't think we need to go over any of this. Do we, Nathan?
Maybe possibly dumb it down a little bit. So, how do we know we have gas pressure on Earth?
How do we barometers that measure it? Oh, I forgot to go over the red herring fallacy argument, but we'll get to that with the fallacy presentation here in a couple days.
I'm getting there, and I'm gonna plug that too. This is
okay.
one kit and caboodle with my leading question. So I'll give you a few hints. The first part of the question, just it's no gotcha, just answer it, and then we'll get to the second part. So, how do we know we have a gas pressure on Earth?
Is that a rhetorical, or are you asking me?
Nah, just give me a straight answer, and then the second part's much more important. You'll see where we're going.
Okay, for barometer, we can measure it and we breathe it. Yep.
Right, perfect. How do we know we've got a vacuum as asserted by globeheads? Space. How do we know that's real?
Well, to have gas pressure, it's a necessary antecedent consequent game. That means you have to have a container first before you have gas pressure. In other words, it's like a cow and a ribeye. Before you can have a ribeye, the consequent, you got to have the cow, the necessary antecedent. You're never going to have a ribeye without a cow existing. So if somebody slaps a ribeye down on my plate, right, I never have to see a cow or had seen a cow in my entire life. I don't ever have to see it. I've never been on a farm, no pictures, no nothing. All I have to know is that ribeyes come from cows. So the evidence for the container is the air pressure itself, or the evidence for the cow is the ribeye itself. The necessary antecedent is the cow. The consequent is the ribeye. The necessary antecedent for gas pressure is a container. the consequent is gas pressure. It's just that simple.
But that still doesn't. That leaves me with a big problem, though, because how can you have space? They say space is real.
Number one, who are they in space? Well, we're not talking about what is space. We got to make sure you're very specific in what you're talking about, because space, like the space between people or buildings or whatever, space exists. It's that thing, that medium between us.
Okay.
This
the vast majority of what they tell us, if I crick my head and look up at the stars, the place that they are asserted to reside is called outer space and is also asserted to be a vacuum. But given that the necessary antecedent to have the gas pressure that we breathe is a container, how can you have outer space?
Well, you can have space between you and whatever you're looking at. However, there is no vacuum of space. That's the key point of the argument.
But satellites are in the vacuum and spaceships are in the vacuum and they're traveling
No, they're not. No, they're not. Not according to their narrative or not, because it has to follow the narrative. It's just like, I think I used the example of mahi mahi, right? If mahi mahi can only exist in the ocean, that's seawater, then if you try to prove that mahi mahi exists to me with anything, I don't care what you do. But if it's already established that mahi mahi live in the ocean, seawater, well, if I disprove the existence of that medium, then I don't have to go down the route of trying to disprove mahi mahi. I just pummel the medium that doesn't exist.
Okay.
Follow?
Yeah, okay, using water though. So if I just change your analogy slightly. So if I assert it, there is a certain fish that lives in a region in Africa in a special medium called liquid wood. And it's wood that's actually liquid and it's home to the mahi mahi. So, yeah. Now, at that point, you've got a couple of choices. Do you A, try and figure out if the anatomy presented on a diagram of the mahi mahi fish is accurate, or do you debunk that there's not liquid wood, therefore debunking the mahi mahi out of hand without you having to analyse anything about it?
I go after the rate limiting step where it exists. It's medium. I pummel that liquid cardboard.
Right. And in this case, the analogy is it's analogous to the vacuum of space. You can't have a vacuum of space. And that is where it is asserted that many of the heliocentric proving things that fall around sphere Earths reside outer space. Shame, really, because it's not possible. It defies the second law of thermodynamics. You can't have gas pressure without a container.
Yeah, exactly. Another one I use is Humpty Dumpty. Right? If before you spin your yarn on Humpty Dumpty, you let it be known that all anyone has ever known was pure anarchy. And you start your story with Humpty Dumpty sat on a wall and all the king's horses and all. Oh, wait a second. Did you say all the king's horses? Yeah. Well, that's a contradiction because you said that all we've ever known was anarchy. So I don't need to disprove Humpty Dumpty. You just contradicted yourself. The whole story's a friggin' fabrication. Follow?
Yeah, new one on me. I like it.
Yeah, I used to use that one a long time ago. It's easier for some people, but yeah. This is a second law of thermodynamics violation. It's really right in your face. You can't get around this one. You can't get around any of them, but this one really puts the screws to you. So what do they say? As soon as you say, how do you have a gas pressure without a container? Well, then they red herring fallacy and say, how do you have gas pressure gradients? Nice. That's a nice fallacy. Do you want to answer my question? Because I got the answer to the second question. You're not answering the question. You're not answering the argument. I got that answer, by the way. So right after you answer that first question and make sure you're within the laws of, within the second law of thermodynamics boundaries, right? I'll give you the answer to gas pressure gradients in a closed system, because that's what you have to have. You have to have a closed system to have gas pressure. Period. End of story.
So that would be classified as a straw man, not to be confused with a red herring. Can you give us just a little taster of that? Because I know we're going to be doing it next week sometime.
You're really trying, you know that? You're really trying.
Well, just so people know what they're in for next week. What's the difference between a straw man and a red herring?
All right, let's give a teaser. So you want to give a teaser, right? All right. Straw man fallacy. When a person simply ignores one's actual position and substitutes a distorted, exaggerated, or misrepresented version of that position. A classic one that's brought up, relatively recently, the claim scientific experiments are conducted to reveal the cause of natural phenomena. However, the fallacy comeback is, how are we supposed to conduct experiments without man-made objects? This is a classic straw man. It's a misrepresentation of the actual claim, right? We're not saying that you can't use man-made objects in an experiment. I want somebody to try to do an experiment without man-made objects. That's not what we're saying. What we're saying is the dependent variable must be natural. That's what we're saying. So this is the classic straw man, a misrepresentation of the actual argument. Right?
And
so
likewise, just so it tallies, the gas pressure without a container question being followed up by, well, how do you have a pressure gradient, would also be a logical fallacy known as a straw man.
Well, I classify, straw man and red herring fallacies are real close. So I classify the red herring fallacy right here with this exact one.
Oh, I'm
Let's
wrong.
do this one.
Okay.
We're gonna stop with this one right here. Okay. So let's go over it. Red herring fallacy. This is a fallacy of distraction. It is committed when a listener attempts to divert an arguer from his argument by introducing another topic, or diverting attention from the real issue by focusing instead on an issue having only surface relevance to the first, right? And this is the classic red herring fallacy with our argument, the gas pressure without a container. Claim, please show gas pressure without a container. The fallacy, how do you account for gas pressure gradients? Wow, that's not, first of all, it's a question. Second of all, you didn't answer this question. Third of all, what comes first? Gas pressure or gas pressure gradient? What has to be first?
Gas pressure.
Yeah. So this is the classic red herring fallacy.
Okay, so my confusion lies with the surface relevance with the red herring fallacy.
Yeah, to be a real red herring fallacy, not an outright just diverting, just changing the topic wholesale, right? It can have a surface relevance. That's the more subtle variety, right? And that's what this is. It's subtle. It's not subtle to me. I recognize it immediately. However, you can see how it can be subtle.
Yeah, absolutely. So yeah, taster for those who are fascinated as I am with the logical fallacies. Tune in next week.
So this is what they call a teaser in the industry.
Indeed.
Are you just trying to pull the wool over my eyes and you think I'd just start rolling on with it, huh?
No, I knew you wouldn't. We've done a good stint, nearly an hour and a half, John.
Yeah, that's long enough, man.
I agree. Cool. Good stuff. So, this all went missing, didn't it? You lost your whole presentation.
Which one?
This one.
I lost like 10 of them. Now, not wholesale, not entirely. What would happen is that it took half of my presentations, or roughly that amount, and just gave me code. However, I have this information in several different places. I just had to go get it again. I had to locate it and then put it together again. That's all. It's just busy work. I just have to go find it. So yeah, that was it was really enjoyable when I went in there one day and I said, "Oh, let's take a look at this one." And I went to find something, and all I got half the presentation, and then the other half I was looking for. Of course, the part I was looking for was in the other half, and it just gave me lines of code. So yeah, that's always enjoyable.
Yeah, you went through the old 5 stages of loss over Skype calls with me, didn't you? First it was anger, then it was denial, then it was bargaining.
Yeah, they go real the bargaining. No, I wasn't bargaining. Mine go really quick. They go from panic to getting really pissed off in like a second. But no, I had them all. Like I said, it's just busy work trying to get them back all again. Um, and in fact, sometimes looking back on it, it's pretty cool because I get to go back and find out where all that information is, all of my research. All this is my research, right? I get to go back and find it, and then while I'm going back looking through the stuff, I'm always evaluating, the research that I've done, always evaluating it to see, number one, is it up to date? Did I come across anything new? Is everything in these statements true and factual? So I guess it's sort of a blessing in a way. It helps me keep everything up to date and everything accurate.
Yeah, I'm sure you'd much prefer not to do it, but it's been
Yeah.
very, very enjoyable having the presentation all the same, John. So first and foremost, I'm going to say a massive, huge thank you to you for actually presenting that to my audience. I'm really, really grateful, as I'm sure the audience are too.
You're welcome, sir. It's my pleasure.
And of course, a massive, huge, enormous thank you to all of the live audience themselves for tuning in and hopefully sharing this discussion. If you liked the show, be sure to smash that like button, maybe subscribe if you've not done so already. If you hated the show, you know what to do. You've probably done it already. But I've been Nathan Oakley, and I'll see you all in the next video.